Just a half hour northeast of Traverse City, in the east arm of Grand Traverse Bay, lies Elk Rapids. Visitors can easily appreciate the expanse of fresh water and fall colors, but what they might not realize is the importance of the Great Lakes reefs below. Spawning reefs, to be exact.
When you look at the Great Lakes, most people find them to be an extremely valuable resource. But most people can't relate to a Great Lakes reef.
When people think of reefs, they often think of coral reefs with bright, colorful fish and lots of diversity. But when we talk about spawning reefs in Lake Michigan, we're talking about this very special habitat of rocky cobble, combinations that have nice clean spaces where eggs can settle in and sit there through the winter and then develop.
Over the last 75 to 80 years, lake trout, lake whitefish, and lake herring declined due to overfishing, pollution, and invasive species. The fight to restore the native fish population is twofold. One part involves reef restoration in Grand Traverse Bay.
It's the only known spot within Lake Michigan that all three species come to and would benefit from any sort of protection from invasive species or habitat improvement.
For the past couple of years, Tracy and her students at CMU, along with Randy and a team of researchers at the DNR, have been studying the reefs in Elk Rapids.
Habitat quality has shown to be a lot more important than the quantity of habitat. So I think that's another really crucial factor. If we can get the habitat to the highest quality that it can be at this restored reef, it would be a lot more important than just having a lot of lower quality habitat.
If native fish have a good spawning habitat, their eggs have a greater chance of survival. A good reef has spaces in between the rocks that can help hide their eggs from predators. But not all reefs are equal. Of the 3 reefs in Grand Traverse Bay, 2 are in good shape. It's the third site, a 100-year-old dock degraded by human use, that is the focus of the restoration efforts. Researchers at the DNR and CMU have been collecting data, comparing egg deposition and reef dimensions at the degraded site to a good spawning reef nearby, the idea being to mimic the good reef.
One of the misconceptions is that a reef is a reef, and the truth is it's not. Even on a small reef, it can produce hundreds of thousands of native fish if it's functioning properly. Pristine reefs have baseball to softball sized cobble that have been polished and smooth surfaces and pushed into piles. When we do the restoration, is we have to mimic the exact size and shape of the spawning habitat. By having baseball-sized cobble rounded in piles, it allows for the optimal spaces between the rocks to protect the eggs.
Another way to help the eggs survive is to keep invasive species out while the fish are spawning in these reefs. Since 2008, the researchers at the DNR and CMU have been studying the main culprits, round goby and rusty crayfish, both of which are extremely pervasive.
From my experience from diving on these reefs almost every day for the past few years, I guess before I never realized how dominant gobies were until you're diving down there and they just carpet the bottom.
Thanks to funding by the Great Lakes Restoration Initiative, they've been able to test different methods of controlling both species. Along with traditional trapping and trawling, they've also tried using newer technology.
Even as we started removing them manually, they would recolonize the spawning reefs within days. That's why we tried the seismic gun or seismic technology, which deploys a huge amount of sound energy and can actually deter or kill many fish.
Though they seemed promising, none of the methods has had much of an impact, yet.
The one thing that we've learned through this project is really how resilient both round goby and rusty crayfish are, which makes them a good invasive species. If you're going to be an invasive species, you need to be resilient to environmental conditions and biotic conditions. And if anything, I am more impressed with round goby now than I was at the beginning of this project, because they can really handle anything that we've tried so far. But we're not going to stop.
The reefs themselves only span half a mile, but to aquatic ecologist Matt Herbert, their size pales in comparison to their potential impact.
The footprint of the reefs is fairly small, but the ecological role of the reefs is very large. When they're working, when they're productive, many, many fish can get produced on these reefs. Those reefs in Grand Traverse Bay, they can provide fish that would move throughout northern Lake Michigan.
As small as it is, a single reef can be crucial to protecting our native fish species. If the restoration is successful, it can also change how people think about habitat in the Great Lakes.
This approach hasn't been used very much in the Great Lakes, and we're hoping it will kind of open the door to thinking about critical habitats and not thinking in terms of the Great Lakes are just ubiquitous or one type of habitat. If we can look at how habitat functions, particularly how it might function better for the native fish, then to me that is an approach that will have long-term benefits for both fisheries but also a healthy Great Lakes.